What's up, everybody? This is Coach Sharp. Welcome back to my Algebra 2 notes videos, slash advanced algebra. Today we are going to continue talking about matrices, and specifically we're going to talk about something called the determinant, what it is, how to find it, how to calculate it. Get all this pulled up. All right, so this is actually going to be a relatively short video. Trying to figure out where I can dock stuff. There we go. All right. So when we're calculating the determinant of a matrix, first thing to note is it has to be a square matrix, so a 2x2 or a 3x3. I actually still didn't look this up. I said during class I was gonna the textbook just shows us doing 2x2, 3x3, and I don't remember off the top of my head because this is the first time I've actually taught matrices, so I don't remember, off the top of my head, even from high school, if you could go bigger and do like a 4x4 matrix with the determinant or not. But it's a square matrix, 2x2 or 3x3. And the determinant is the difference of the products for a 2x2. For a 3x3, it's actually the sum of products, which we'll look at what that is in a minute, of the elements on diagonal lines. Remember, elements are just the individual numbers in the matrix in the correct order. Very wordy, doesn't really help you. Really just got to see it in action. Okay. So let's start with a 2x2 matrix. Okay. The diagonals you're going to make are going top left to bottom right. You're going to multiply those together, A times D. And then bottom left to top right, C times B. And then you're going to take the difference of those so I'm clicking on the color. There we go. Minus CB, and that gives you your determinant. Okay. So there are some real world uses for determinants. Let me kind of add this in before we go further. There are some with 2x2s. The main one though, which would actually be a 3x3 matrix, which we'll look at in a minute. You can actually calculate the area of a triangle that is plotted on the coordinate plane using the 3 ordered pairs of the points of the triangle, and put them in a 3x3 matrix with some other stuff. You can actually calculate the area. So there are some real world uses to it. It does honestly just kind of seem like one of those things that somebody 300-400 years ago with no technology was just playing around with stuff and came up with it. But there are real world applications. There's some validity to it. Anyway, let's look at the couple 2x2 examples real quick. So 2x2 is super easy. Super easy. 2 times 4 is 8. 1 times 5 is 5. I'm going to do 8 minus 5, which of course is 3. That easy. Okay. So I'll pause for about 10 seconds or so. Actually on the video, y'all can actually pause the video yourself and work out the next one, however long that takes you, if y'all want to try it on your own before I put it up. But again, I'll actually pause for about 10 seconds real time. But y'all can actually pause the video if y'all need to try to work out the second. All right. So I got 6 times 5, which is 30. I got 3 times -2, which is -6. So what this actually gives me is going to be 30 minus -6. So 30 minus -6. When I subtract a negative, of course, it turns positive. So that would really be 30 plus 6, which is 36. 2x2s are that easy. Okay. 3x3s are tough. Okay. I'm actually going to move these up here now. So I have a little more. 3x3s are a little more difficult. So what you have to do on a 3x3, you're going to be given this as it is, 9 numbers, right? First thing you actually have to do is rewrite the first 2 columns outside of the matrix, after the matrix. Okay. Like that. You're then going to have now 3, if we use the same colors and the same directions as we did up above, you're going to have 3 green diagonals and 3 orange ones. Okay. So this first one, you're going to get A times E times I. Second one, B times F times G. The third one, C times D times H. Okay. And again, so hopefully this will be less confusing and should be more so when we see the numbers. But on the last one, when we did AD, we didn't actually write, the example I did with y'all. I did for y'all before the one you tried on your own. I didn't actually write 2 times 4 here. I just went ahead and multiplied and got 8. So same thing here. We're not actually going to write, if this was 2, 3, 4, 2 times 3 times 4, just go ahead and multiply it all together. Y'all didn't see me pointing at it. I said if A was, I'd show that. If A was 2, E was 3, and I was 4, I'm not going to write 2 times 3 times 4. You can just go ahead and multiply it all together, either, in your head or on the calculator, and get 24. So you're going to get 3 products. You're going to add those together. Okay. And then you're going to still subtract these 3 products. GEC HFAIDB. So you're going to add those 3. It's supposed to be GGC HFAIDB. You're going to add those 3 products together. And then you're going to subtract, again, same thing. The green one's going top left to bottom right from the orange one's going bottom left to top right. Okay. So let's dive into an example for this. Again, hopefully once we see the numbers, it'll be a little easier. This first one, I already rewrote the first 2 rows over here. You can clearly see that. So I already rewrote them. So I'm going to make diagonal here, diagonal here, diagonal here. 3 times 0 times 1. Anything times 0 is going to be 0. 4 times 6 times -2. Again, that one I can just kind of go in order in my head. 4 times 6 is 24. 24 times -2 is -48. -1 times 2 times 3. -1 times 2 is -2. -2 times -3 is +6. So let me move my head down. So my first sum, sorry. Yeah, we're adding these. So I'm going to have 0 plus -48 plus 6. Okay. Actually need to move this too because orange is about to take up a little room up here. So now I got to go bottom left to top right. Okay. -2 times 0 times -1 is 0. There we go. -3, 6, and 3. Again, you could do -3 times 6, then multiply it by 3. I see it and I automatically switch in my head. Let me do -3 times 3 because that's -9, and I still have single digit times single digit after that. -9 times 6 is -54. But whatever order you want to do it. Then 1 times 2 times 4. 1 times 2 is 2. 2 times 4 is 8. So now, let's see if I can fit this in. We're going to have minus 0 plus -54 plus 8. There we go. All right. So combine together all my green. 0 is basically just going to get rid of itself. So -48 and +6, add 6 back, gives me -42. The minus sign in the middle. Minus sign in the middle right there. And then again, 0 can't, 0 doesn't cancel out, but adding 0 is not going to do anything. So you get rid of it. -54, add +8 back is -46. Again, I put in parentheses. I realized I didn't do it right here. I just wrote -6. You could have put in parentheses. Doesn't matter. But I got -42 minus -46. Again, this 2 negatives in a row turn positive. So -42 plus 46 is 4. All right. Okay. Again, I'm going to pause for 10 seconds in real time and let y'all try the second one. It might take y'all, again, a little more time than the first, the 2x2 y'all did on your own did. The one thing I'm going to say, I'm not going to go ahead and write it out, but remember, you got to rewrite your first 2 columns first before you start getting your diagonal. So I'll give y'all, again, I'm going to stop talking about 10 seconds real time, but pause the video if y'all need to and try that next one. All right. So I think it's still black. You got to rewrite the first 2 columns. 2, 1, 3, -3, 6, -1. All right. I changed some colors here in my head for a sec. All right. So top left and bottom right. Going here, here, here. 2 times 6 times 5. Again, I see 2 times 5 is 10, times 6 is 60. -3, 0, and 3 is 0, because there's a 0 in there. 4, 1, -1 would be -4. Then going back bottom left to top right. 3 times 6 times 4. Again, whatever order. 3 times 4 is, the way I see it, 3 times 4 is 12. Times 6 is 72. Do 3 times 6 is 18. Times 4 is 72. 6 times 4 is 24. Times 3 is 72. Punch it on your calculator. However you do it, but you get 72. -1 times 0 times 2 is 0. 5 times 1 times -3 is -15. So I'm going to have 60 plus 0 plus -4 minus 72 plus 0 plus -15. I did get two parentheses in there. So again, the mid both of them actually have a 0 in the middle, which you can basically cross out. 60 minus 4 is 56. Minus sign in the middle. 72 minus 15 is 57. 56 minus 57 is -1. All right. So a couple examples each on getting determinants. Again, it's not getting any more challenging than that from what we showed. I mean, I can show you all a couple examples with different numbers, but I mean, it's gonna be the same thing otherwise. So there's the video on that. I've got your assignment. As always, if you've got any questions, let me know in your mind. Otherwise, I'll see y'all in class.